while you read this quick trivia question, how many of us have played badminton? Quick raise of hands. Does anyone know the original name of badminton? And this is going somewhere, but no? So I come from the town that invented badminton, where it started. The original name of badminton is Pune, and that's the place I come from. The reason I mentioned that is during this talk, you will also see me sharing some of the pictures and imagery of that city that I love, and that will hopefully add to the context that I'm going to talk about. So I'm Sudhindra. I work at JFrog. Currently, I am the development manager for Persia, the project that we just announced as part of CDF. And I wrote this talk when we were actually researching the reason for securing supply chain and open source. And we were sort of exploring what is happening in the open source world and how the supply chains are being managed, and that's where some of these ideas came to mind. And I need your help here. So instead of just writing an agenda, I thought I should phrase it in a way so that it is more participative. So during this talk, I'll try to share some of my experiences. Hopefully, I'll be able to share how I have learned open source software being built and distributed. And you'll also learn some of the community efforts. But I need your help to make it a really great talk. And this can be a great talk if you are able to participate, if you are able to take this message back and come back next year by bringing contributions to these projects that I'm going to talk about. Let's go back a little bit into my experiences. I came from a world where I was working on Ruby projects where 2-minute builds were really the rage. We used to talk about how they reduced 3 seconds and 5 seconds on a test. And then more recently, I actually was building a Kubernetes platform with a name that ends in KS. And the task of that Kubernetes platform was to be able to run on any cloud of your choice, any cloud, and also on-prem. And let's walk through the journey that we took, taking the newest release of Kubernetes, packaging it, adding integrations, and what it looks like. Hopefully, this will give you an insight on what, or this may be similar to what you're using in building your proprietary software. So we had some source code. There are some components that came together. There were integrations on that Kubernetes platform, like networking and observability that are not part of the Kubernetes platform. So all of these are built, and they take X number of minutes to build individually. The really heavy task comes when we start building these on variety of configurations that these need to be deployed. And the reason I stopped at 49 is that those were the number of configurations we were building on this platform. Each of them then went through some acceptance testing, some of which was manual, and then we used to publish a downloadable binary or downloadable software that people can install on cloud of their choice. Now, just to put some stuff into context, each of these pipelines took 8 hours, right? And that added up. So it used to be a whole 3-day effort to bring up a new version and then figure out if things broke and so on, right? And this is the kind of rigor we put in developing a proprietary software, right? This is a dedicated team trying to build things. Everyone knows everyone, or at least they can be traced back to what they are doing. Every commit can be traced back to a system that it came from. And if a component build failed in the integration, we could go back to the component team and say, hey, this is the PR that it went down to, right? And this took about 3 months of effort, right? This is the continuous delivery world. But it didn't go to production. After it went to a public download, our customers used to download it onto their staging because it's a platform level deployment, and then bugs would be found, and we used to do some work in going through the integration loop, right? And then people used to manually go through and figure out the provenance of every single thing that became part of that build. Every single open source software, every single small library that has been used all the way to the top, right? And this is manual because there is no infrastructure that will give you all of this information and no trustworthy information. And some of this was required for security, like identifying CVs and all of that. Some of this was required for legal purposes to ensure that we didn't violate copyright and all of that. And are we done? We're still not done because there is some process that happens, like there's some marketing that needs to happen, some legal documents needs to be signed. If you are in a HIPAA or such environment, then some signatures have to happen, and then general availability happens. So this is the rigor that we put in. I know this is a far-fetched example or an extreme example, but this is the rigor we put in to bring continuous delivery on proprietary software. Now let's reflect on what it means or what we do to get to the same level of open source, and are we even there at the open source? The reason that these are good practices is that we have a dedicated team, all of them know each other. There's an inbuilt trust, and how do we do that today? In open source, we know these are some of the research data I found from my references. 78% of the code that is currently shipped is open source, meaning out of all the code bases that are shipped, 78% of the code in those code bases is open source. Almost all projects are dependent on some open source somewhere, right? And we have come a long way in adding automation at various levels to help with releasing them. And Linux project itself is a very good example. But how does it scale? When we decide to use open source, we just think, oh, it worked for Linux, so it must work for other projects. So we just go by and do the search, find the top, either it's a download, either it's the GitHub stars or whatnot, and pick that, and or the most used that is our quick rubric to identify a good project. We find badges like that, saying that if it is green or if it's some salsa level or something that is flashy, we go after it and pick that one. Or we look at the GitHub stars, like I was saying, or if there are more forks, that means there's more community around it. But is that enough? And this is what I think when I think about open source, right? Open source is infrastructure. And this is a picture of Mumbai-Pune expressway that I love to ride, and it is really beautiful during the rainy season because there is rain coming down and there are clouds, and it's amazing. And it works really well when infrastructure is in good shape like this, right? And what happens when that is not the case? When that is not the case, this is another picture from Pune where there are famous restaurants and really good locality, and it survived all the rains for last 50 years, but there was some rains like last week for an hour, 2 hours, and the whole system just choked. And the whole system just choked because there was no obvious drainage for the water for such torrential rains, right? And this is something similar to what we see in open source, right? Log4j is hacked, and that's it. The thing that worked for us for years and years is now in trouble, and we don't have a way to protect it, right? To improve the infrastructure system, I mean, some solutions are obvious that you need to put the right drainage system so that this doesn't happen in the future. We need similar things in open source. And if we look in a similar way, if we look deeper onto those projects, this is what I see in Log4j. And I know that people are working on this, so the workflow is kind of disabled right now. Maybe they're working through some things, and last few builds are red. So this is not really, this is what my software depends on, but this is the trust level I have. REST client, the one I showed, has had a name squatting last week, right? So again, and the third thing that I showed you, which was Salsa level 3 project, that actually is not a project. That's a ping server that is no-code ping server that was demonstrated by Kelsey Hightower in a recent talk. So I just picked that, and that doesn't exist even. It's because he was demonstrating how you can fake salsa levels just by putting badges, and that's what it is. So we rely on those kinds of trust mechanisms, and that is very weak. And some more like emphasis on how open source is sort of ingrained, right? If you build a web app, that's how much open source software is as part of the web app. If you look at very famous libraries that everyone here knows, right? Pandas, people probably know or have used it. It shows that it has 1,400 committers, but the actual work is being done by 4 people. How can you expect the 4 people to have a complex, a mature CD system? You can't. They need support. And there is this trust or inbuilt trust that, oh, what is this person going to do wrong just if I give them access? Well, this person can write a script that can steal Bitcoin. That's what happened on a recent project that is an event stream library that was very popular. And the original maintainer said, hey, I'm getting help. Maybe I should just trust them. And what could they do wrong, right? And this is what happens if you put a trust in the people that really don't deserve this. This is another picture of floods that happen in Bangalore, and this is not to critique the infrastructure, but sort of showcase how the parallels are. This was luxury housing built on top of lakes and sort of reclaimed land, and this is what happened after 3 days of rain, and people had to be rescued through boats and all of that, right? And this is the kind of stuff that is happening with our software. Somebody just giving the keys of the city to people who don't know how to handle infrastructure, and here we are. And this is the most used slide, I think, in the talks we heard today. But dependencies, the small dependencies that we blindly use, if you actually run a Hello World application in NPM, it seems there are about more than 1,000 dependencies that come with it, and we don't pay attention to those. And this is just the first level dependencies, and there are transitive dependencies. The other day I was assessing, why is my application using OpenSSL? I found out that OpenSSL is being required by native TLS, and that is required by Tokio, which is a async library for Rust. And I only picked Tokio. I'd never paid attention to that, oh, now OpenSSL is required. And it's important in this context because OpenSSL also has difficulty in being compiled for different operating systems, which was what we were trying to do. Right? Dependencies are so hidden that we really don't know where they came from, and we don't really pay attention to how they're being used, right? And this is, I think this is a well-known story where a bridge in Pennsylvania was on its knees already, and the infrastructure bill was the impetus to fix these kinds of problems. So we need that kind of emphasis to improve the CD etiquette for open source. And generally, people talk about GitHub when we talk about open source, but here is a research that actually compared GitHub and other places where open source software is, and it found that more or less the number of committers for every project stays the same between 2 and 10. It's not a big team. They are doing it more on a philanthropic basis. They are doing it on the side. It's not their full-time job, but they're still trying to support it. So we need to put more people, more energies there. So talking about doom and gloom, what can we do about fixing the CD etiquette for our open source, right? There must be some things we can do. And I want to share some of the work that has been happening before the pandemic and even through the pandemic. At JFrog, we believe that in our future, we will have liquid software that is automatic updates and continuous in that fashion. And for that, we need a supply chain that is automated as much as possible, 100% automated if possible. Remove the human parts of my build pipeline that I showed. It needs to be trustworthy. It can't depend on the badges and the stars and all of that. And it needs to be dependable. I need to know every single detail about every single dependency that I'm using. Also, this system cannot go down. You cannot have the situation where NPM or US East 1 was down and it stops going to production. It's not so much just going to continuing development, but continuing to release to production. So in the last few years, there has been more emphasis on protecting the supply chain. There have been tools that allow you to write software bill of materials. There is also government emphasis regulation on how to improve the cybersecurity etiquette. And some of this is required, regulation, literature, so that the practices start flowing. But this is not going to be all. Regulation is going to operate at a higher level, and it's not going to flow into practices as fast as we want. So there needs to be action from our end. Some of the, and this is the most talked about research around software supply chain, and the first thing this does is this lays out the land to showcase what are the places where software is vulnerable, right? And this gives us something to play with and figure out, if our tools are capable of handling all this. And if you compare this with my original CDE flow, this is much less complicated. And in a real life situation, there might be more attack vectors that you will need to handle. But this is a good reference, right? So we'll use this reference to understand what has been happening in this field. There has been some work in trying to sign the stuff that goes into production. Sign your images, sign your Docker images that go into your Kubernetes deployment. Notary is one such project. Now it is in the second phase, and the project is called Notary V2. Basically, the idea is to make sure that when you put any image into production, that is already signed, and it cannot be tampered with, and so on. So it allows you to do continuous delivery on that, because a lot of those signing verification processes are now automatable, right? And that tries to solve the very end of the supply chain, where the the images are being shipped to your Kubernetes clusters, right? So that's good. That's a good start. There's another project called SigStore, and it tries to do the same thing, signing, but with a lot more variety of ecosystems. Now you can sign your PyPy packages, now you can sign your Ruby gems, so you can sign your Java packages, and so on, right? And you can take it all the way to through your supply chain into Kubernetes. So if you haven't looked at these projects, go look at them and at least find out how you can use them. And the SigStore and the projects underneath do a little more. Like I said, they sign, and you can verify all of those at the end of the supply chain, and at the beginning also, when you start consuming them, you can verify that, hey, this thing that I'm trying to download is now signed, and I know that it came from a certain developer. Is that enough? There are all these things in between that need to be addressed, though. Tekton Chains is another project which allows you to take it for Kubernetes deployments that are on Tekton all the way through the chain, right? Same thing, tries to address the one end of the supply chain, and we need that. We need to know what goes into our production. Yeah, right? And when we looked at the landscape, that is what we found, that we need something that allows you to build those dependencies better. And that's when we started investing time in building this, and we called it Persia. So what Persia does is actually allows you to build from source. You can take any open source project and build it from source. You can figure out how it was built. You can verify that it was built in the way that you wanted it. It also does So Persia tries to sort of fix or help with the situation where supply chain needs help with building from source and verifying and approving all the binaries that you're going to use into production. One of the other things that Persia does is that it doesn't trust just one build system. It has an inbuilt mechanism to run the same build on multiple machines and randomly chosen across the network. Persia runs on a peer-to-peer network, so these builds are just shipped, sent across to different random nodes, and when they build and then they verify that they got the same result, only those builds are actually submitted to the network so that they can be downloaded by anyone who is looking for a binary. So this is something similar that people are doing to ensure that there are no single points of attack like the ones that happened in SolarWinds case. So this is something that they are investing in it. And Persia also has a provenance log, so you can actually write automation to figure out where certain thing came from. And it's not just the stars. It tells you that this binary was built from this Git SHA, and these were the steps that were run in building it. Here was the end result, and then it is stamped with vulnerabilities, even the known vulnerabilities at that time, and you can ask these kinds of questions. What this allows you is to write automation on top to actually make release decisions. So you don't have to wait and figure out, somebody has to go and do a due diligence on whether this binary is something that I can use. And there are few more projects that I wanted to talk about, because as I showed, it's not enough that we have the simplistic supply chain covered. Persia, to work well, needs to have reproducible builds, because only reproducible builds can be verified against each other, right? So there is a project which Google open source team is, I think, doing around reproducible builds, and it's a heavy lift because people have a lot of variety of ways in which they can get to the same result sometimes, or they have a very complex ways in which they get to the build, and in between do many other things. And what the Google team is trying to figure out is what is that one script that you can derive and make that build reproducible. Another thing that we overlook is GitHub stars and Salsa badges. They don't tell you what is happening real time with the libraries that you're using. Let's say you download an Alpine image 3.15.1, what are the vulnerabilities that you're facing? Is that vulnerability in your development, staging, or production, and how are you going to handle that? So there is more stuff happening around integrating vulnerabilities into the CD pipeline itself, and Persia is going to do that. This is another project where you will be able to find out about the vulnerabilities right when you start downloading. And the Go team is actually trying to bring that in one platform. And the Go team tries to address this problem for one ecosystem. Persia team tries to do it for a lot more ecosystems, not just for Golang. But that's a start. So this is something where we need to put some emphasis on. So just doing a recap. I shared some projects that allow us to address some of these attack vectors. They're not a complete list. There are way more things that need to be done. There is automation that needs to be built on top of this so that you can actually have a continuous delivery pipeline that looks more continuous and not as broken as it is today. And as you see, there are still some gaps. How do we make sure that the source that is coming from a source control system is secure? How do we make sure that the source control system is not compromised, right? There are some unsolved problems that other teams are working on. And we need way more tools to cover the entire supply chain. So here, I want to sort of summarize with a call to action. You should go back and find out if you do have a good continuous delivery plan for your open source. Have you used any of the tools that I mentioned? If you're not, do you find any opportunity to do that? Let's do this as a community. From the get-go, we found that people are doing these one-off solutions, and some of them work for them, and some of them not. But this is open source. We need to invest in this together and make sure that we are trying the same things, and we build the same trust mechanism instead of bank A trying to invent their own and company B trying to invent their own, right? And time to act is now. The supply chain software is under attack. We need to do it now. And this is also an opportunity to sort of wish happy Diwali to all of you. We are celebrating Diwali this week. And today happens to be the day when actually businessmen in India, they open new books, they start new projects. So if you're waiting for the right timing, today is a very good day, a very auspicious day to start contributing to any of these projects. Thank you. Good question. Actually, yes, X-Ray is very good at going through your registry or repositories and identifying what vulnerabilities exist. What X-Ray doesn't do is it doesn't tell you how the software was built, who built it, where it came from, whether it was built on multiple systems, whether it came.
Where all your dependencies are, where the licensing came from?
In a way, but it is very much focused on vulnerability. Yeah, it is very much focused on vulnerability. Yeah.
Yeah, well, yeah, so if you add in the build info,
Yeah.
you'll get that information.
Yeah.
And then X-ray goes through, kind of looks, to me, it's very similar to check marks.
Yes. Yes. Yes.
And so why would you want to go through all of that rather than catch that just in the beginning of the CI/CD build and then just fail it right there?
Good question. So the question is, why would you not just use X-ray and instead of what we just talked about, instead of Persia? So the answer is X-ray is also meant for your proprietary systems, and it works as a product when you have configured it for all the things that are important from your proprietary perspective. What we are saying is that we need that etiquette of X-ray to be used by everyone here. And we can't just have companies who have purchased X-ray doing that for their open source and doing that, individually and trying one-off solutions. What we are saying is we need something that we all can trust, and we all can trust in the same way, right? So Persia provides that, because then you are looking at the same provenance log that I am looking at, and we are making the same decisions. Because the provenance log is also telling me that my log4j has a vulnerability, and then the new version doesn't have that vulnerability, so it's okay for me to release it. And you have the same information. So that gives us way more control on how we deal with our open source, right? And for open source, we think the solution has to be open source, and it cannot depend on the tools that companies are able to buy. There are some companies which do critical stuff, but they are not able to invest in. Like I said, right? Even the log4j maintainer, they don't have access to X-ray, for example. And we are trying to provide that via various means, but they won't have that expertise.
So you're looking further in than just the, say, log4j. You're looking at all their transitive dependencies to that.
We will have the ability to look at, yes, because we will build log4j, and then we'll build the dependency and the dependency and dependency.
Kind of like from a Maven perspective, because
Yeah.
it's kind of like looking at the effective POM.
Correct. Yes. So we will be able to like effective POM, and what we just released is the first level, and then you will see the nested structures come out of that as well. So you can ask the questions of that nested structure. Am I using OpenSSL? We can't ask that question today, but you could ask that question to Persia, and you will know. Any other questions? Hi.
Yeah, what we are seeing is everyone is talking about CVEs or CWs, but not configuration issues, like a Docker file running as root or Kubernetes manifest running as privileged container. And all these files are also shipped with the open source libraries or applications. So you do use Rigo policies, for example, like pass or fail. Do you guys have any plans to include that info, which is not conventional as Baba? You want to say running as root, running as privileged container, has 50 other dependencies that shouldn't be on Alpine Linux, for example, like that type of thing.
Yeah. So the question is, are we thinking about configurations and artifacts that are not traditional binaries, right? So at JFrog, we use the term binaries to cover any type of software that goes into production. So we consider the configuration file as an equivalent of binary. That needs to be stamped, that needs to be verified, that needs to be run on multiple machines to make sure that it produces the same result as well. Yeah.
Artifact. That's an artifact.
Yeah, yeah.
Plain text file. Which I'm asking, do you have any plans to integrate Rigo policies? There are like 300 plus public policies out there that gives you clear fail or pass.
Yeah.
Or compliance perspective. Mostly.
Yes. So we started small with Persia, and we started with Docker images and Java builds, but we are expanding to other ecosystems that go into binaries, right? So even implementing these kinds of policies can become part of Persia.
My only question is like why, I think most of this should be caught during the build process when you're pulling in the dependencies into the build rather than waiting until it's already been published.
I think the question is, most of this should be caught when we are trying to build instead of trying to publish. And I agree, completely agree with you. Most of this should be caught when we start to ingest it. But we don't have tools that allow it allow that deep an analysis. And what we are saying is, yeah.
The parser can do it if you're in a Maven environment.
Right, right. Yeah, and there are
But NPM cannot.
cannot exactly, and that's the problem we see. That one-off ecosystems do have mature tools like Maven and what you mentioned, Kyra. They do have some tools that allow you deeper insight, but there is no good singular platform that allows you to answer that.
Okay,
Thank you.
thanks, Surendra.